Hi there, I'm Alex the Pi Guy, and welcome to the 5th lesson in this series where we're going through the Grade 9 Academic Mathematics curriculum. In this lesson, we are going to be solving equations, the stereotypical find x or solve for x sort of problems. So to start, I've provided an example of a sort of problem that you might encounter. 2x minus 3 is equal to 4x minus 2 plus 5x. So the goal is to get an x by itself so I know what x I can put into this equation that will solve it. The nice thing about these problems is once you've solved for x, you can actually go back to the original equation, slot that value into the problem, and the left side should equate to the right side. So it is a nice little verification step you can do really quickly. So the first step is we have to decide which side of the equation we're going to put the variable that we are trying to find on. Typically it's a letter, so what I've always been told is put the letters on the left. So we're going to put the letters on this side of the equation. Now we can't just pick them up and move them over here, that'd be way too easy. Instead, you have to balance the equation as you do this. So you need to move things over by doing an inverse operation to remove it from this side, and when you do that you end up putting it on this side. Whatever you do to this side, you do to this side. For instance, I want to put the letters on the left, so I need to move this 4x and this 5x to this side. To do that, I am going to subtract 4x and subtract 5x from this side. By doing that, those will cancel these guys out. And to keep it the same, I have to do the same on this side too. So I subtract 4x and subtract 5x. Now, I want to take a side note here. If you saw the last video on the order of operations, you might be asking, well, this minus 4x is all the way over here, and this 4x is all the way over here. These guys can't cancel each other out because of the order of operations. Well, thanks to a property of addition called the commutative property, that basically means that, well, if I have A and I add B, well, that's the same thing as taking B and adding A. Because of that property, anytime I'm adding things, I can just kind of keep swapping them around, and eventually I can rearrange it to the way I want it to. That only works, however, when you have a string of additions. The caveat here is that we have a minus 4x. However, minusing something, that's the same thing as just adding a negative. So I can really do the same thing. As long as I write it as a negative number and I change this to an addition, I can rearrange it as long as it's just a string of additions. The same thing is true for multiplication. If I have AB, that's the same as BA. And if I have A divided by B, well, that's the same thing as A times 1 over B. And I can put that on either side, or I can combine it as a fraction. So getting back to the example, we know now that this guy can subtract this guy. So these guys cancel out, and these guys cancel out. You can see why I added and subtracted them, because now I'm only left with this minus 2 on this side. There's no other letters on this side. I've moved them all the way over here. Now I have this 3 over here that I'm subtracting, so I'm going to have to add 3 to get rid of it on this side. So I add it to the left side, I add it to the right side, and minus 3 and positive 3 cancel each other out, hence why I did so. And now all the things with a letter on it are on the left, all the things without a letter, the constant terms, are on the right. The next step is called collecting like terms. So we take powers of x and we group them all together. So right now we only have powers of 1 of x, and I believe for this course that's all we'll have to work with. So we basically ignore the fact that there's an x there, and we just add the coefficients out in front of them together. And that'll give us the total number of x's that we have. So 2x minus 4x minus 5x is, well, there's an x, 2 minus 4 is minus 2. Minus 5 is minus 7. And then we collect like terms on the right side. We have these two constant terms, so minus 2 plus 3 is 1. So we have minus 7x equals 1. Now, we don't want to know what minus 7x is. We want to know what x is. So again, we do a reverse operation. This time, since we are multiplying by minus 7, we are going to divide by minus 7 to get rid of it from this side and move it to this side, because whatever I do to the left side, I do to the right side. So I divide by minus 7. Now, negative 7 divided by negative 7, you'll see that these negative 7s are going to cancel out. It's going to be left with 1, not 0, 1. But 1 times x is the same thing as writing x. So that's actually what we're looking for. And we're left with 1 over negative 7. Typically, you don't leave the negative on the bottom. You either move it to the top or you put it out in front. So sometimes you will see it like this, or it'll look like negative 1 divided by 7, like that. Either is acceptable. When I'm going to be doing more computations, I leave it like this. If it's a final answer, it looks a little nicer when you put the negative in front of the fraction. And that should be the answer to the problem. Now what we can do is we can take this and we can put it up here, and we can solve the left side, we can solve the right side separately, and if this is in fact the answer, both sides should be equal. So we will do that next. So to verify the problem, we just take one side at a time, and we put this value for x into the equation. So we multiply these two numbers together. Now we do the subtraction. We're going to have to work with fractions here. So the equivalent fraction for this 3 is 21 over 7. And we're left with minus 23 over 7 on the left side. I'm going to go up here. I'm going to write left side equals minus 23 over 7. Now on to the right side. So I've already substituted the negative 1 over 7 in for the x value. I like to keep the brackets there just because oftentimes you're multiplying anyways, and if you have a negative number, just having the brackets there is handy. So we do these multiplications first. Minus 4 over 7 minus 2 plus, keep in mind here that this negative is going to change this addition to a subtraction. Now I'm also going to change this 2 into a fraction with a base of 7, so the equivalent fraction here is 14 over 7. This is just going to make it a little bit easier on the next step when I go and add everything up. Now I go minus 4 over 7, minus 14 over 7, minus 5 over 7. That's 18. That's minus 5 is minus 23 over 7. And minus 23 over 7 is what we got on the left side. So that is verified. Now something to note here is that if you had multiple solutions to the problem, verifying one solution doesn't tell you if there are other solutions. However, for the types of problems that you will be doing, there is only one solution if there is any at all. It is possible that there is no solution, but you probably won't see that, and if you do, you'll see it very infrequently. You won't be dealing with situations where you have multiple solutions until grade 10. So for now, you just have to worry about finding one solution, verifying that it's a solution, and you're done. So that's really all there is to it. To summarize it, I've written them all out here. Just to note that we actually start at the second step here. A lot of the problems that you're going to be given are going to start right here. There are going to be some times where you're going to start up here, and we're going to look at some of those cases in a few lessons to come. But for the most part, you're going to be given stuff starting here, and you're just going to work down. So to start, you expand any brackets you have, any operations that are on the brackets, just so that you're left with that string of addition and subtraction terms that we can use that commutative property to move things around with. Then we can move things around by adding and subtracting the appropriate terms on both sides of the equation, so that we only have letters on the left and our constants on the right, or the other way if that's how you like it. Once things are by themselves, we collect our like terms, then we divide by any remaining coefficient that happens to be on our x, and we should be left with x equals some sort of number or expression or whatever it is we're looking for. And that's it for this video. There's going to be another video coming out later this week where I'm going to work through some more practice problems with you so you can get a better feel for how to do this. And I'm going to point out maybe some things that you might get wrong on your homework or some things you should look out for. Following this, I'm going to have an aside where we're going to talk about just some other inverse operations. All of these problems where you're going to use these inverse operations, you're probably not going to use in this course, but you may use them in other courses coming up in later years. So it might not hurt to see what they are. If you're not sticking around, then thank you so much for watching. If you like this kind of comment, feel free to drop me a subscribe if you'd like to see more, or just drop a like on the video. If you have any comments, feel free to leave it in the comment section to let me know what you think. Letting me know what you liked, what you didn't like, what you'd like to see more of. And I will see you in the next one. Bye. Alright, on to the aside. We're going to look at some more inverse operations. This stuff is probably the kind of thing you might not see on your homework, but you might occasionally. So I just want to give you the exposure to it. So in this first one, you have a second variable that you're not being asked to solve for, but is present on all terms. That means all terms on the left and all terms on the right. So here we have xy equals 2y, and I'm asked to solve for x. What I would do here is I would divide by y. Now the catch is I can only do this if y is not 0. In the case where y is not 0, then it works just fine, and I get, in this case, x equals 2. But this, again, I have to write down that y can't equal 0, and this doesn't tell me anything about y. In the event where y is 0, we can actually put it into this equation here, and you'll see we just get 0 equals 0, and we can't actually solve for x. So in the case where y is 0, x can actually take any value, and it will solve this problem just fine, because anything times 0 is still 0. Unfortunately, when you only have one equation, you can't really solve for multiple variables unless you were to deduce some more information based on the functions that are in the equation. But because we're just working with simple linear equations here, we can't really deduce anything about any other variables other than 1. The second inverse operation I have here is we're looking at a power. So in this case, I have 5 times x squared equals 125. The first thing you got to do is you have to get the thing that the power is on by itself. So I divide by this 5. Yeah, x equals 25. And from there, I can do a square root. If you watched the aside when we introduced exponents and we talked about fractional exponents, you might remember that a square root is actually an exponent of a half. And if we use our exponent rules, then we can write x squared all to the power of a half. We can multiply those two powers together. And 2 times a half is just 1, and so we are left with x to the 1 equals 5, but x to the 1 is the same thing as x. So if you have any power, you take the appropriate root, and that will get rid of the power. You just have to make sure that on the one side, the thing with the power is by itself. Now, another note here with roots specifically is that there's actually 2 answers here. X can be positive 5, or x can be negative 5. And if we actually take each of these solutions and go into the equation up here, we'll see that they both are valid answers. And that's because when we take a square of a negative number, it's going to become positive anyways. So the square of a positive and a square of its negative counterpart is the same. And so anytime we take a square root, a fourth root, a sixth root, any even numbered root, we have to consider the fact that there is going to be a negative value as well. I'd just like to make that point a little bit more clear about having that squared thing by itself. So if I want to reverse the operation of a square, it has to be the only operation on the outside of, say, a bracket or something like that. So here I have x plus 5, all of that squared. I can take a square root of that, and that square root will cancel each other out. However, in this case where I have x squared plus 5 squared, if I take a square root here, it doesn't actually cancel both these squares out. The last inverse operation I want to cover is when you have the variable you're looking for is on a denominator. So for this guy, all we do is if the variable we're looking for on the denominator is by itself on the only term on the one side, then we can put everything to the power of negative 1. Like so. Now keep in mind that I can only do this because we have this term by itself. If I had 3 over x plus 1 over 2, if I take the inverse of this guy, then what's going to happen is I'm going to take the inverse of the whole thing. And I don't really want to do that because that doesn't really help me very much. I might be able to figure it out. This isn't really what I want. So once I've taken the power of negative 1 on each side, then I can apply it. And when I take the power of negative 1, all I do is I flip things around. So I'm left with this guy, and this is pretty easy. So I multiply by 3, and that just leaves me with 1 over 9. Anyways, that's it for this aside. That's it for this video. Remember, later this week there's going to be some practice problems up. But if you liked what you saw here today, please drop this video a like. If you want to see more of my kind of content, drop me a subscribe and let me know in the comments what kind of things you liked about this video. I'm Alex, and I will see you in the next one.